Alright fellow shinobi, hold on to your kunai because we're gonna see Naruto through a data-driven lens. In this video, we're gonna use the techniques of web scraping, advanced NLP models, and data science to extract insights within the Naruto anime. We'll start by scraping data from the internet to build a comprehensive dataset about the anime using Scrapy. But that's just the beginning. We'll also use Spacy's NER model, networkx, and pyviz to create an intricate character network. Then we'll extract the main themes of Naruto using zero-shot classifiers. And that's not all, we'll be training a text classifier that can identify different jutsu types based on their titles and descriptions. So grab your ninja headband and get ready to unleash your inner Hokage. Now that we have a general understanding of what we'll be doing in this data science project, let's dive into the first step of the process, collecting and scraping data. We are going to have two main datasets in this tutorial. We are going to just download the first one, and we'll scrape the other one from the Narutopedia website. For the character network and theme classification, we'll use the anime subtitles. We can download the subtitles from this website. I'll link it in the description below. After downloading, we can unzip the file and rename the folder if we want. The folder contains a file per episode. For our Jutsu classification model, we'll be using the Narutopedia website to scrape jutsus with their titles, descriptions, and types. This web page has links to all jutsus in the anime across multiple pages. When you click on a link, it's going to show you information about the jutsu, including title, description, and type. To start scraping this website, we'll need to pip install Scrapy. Scrapy is a framework for extracting data from websites simply and easily. To get started, we can copy-paste their boilerplate code that we can find on their website. This code defines a new class called BlockSpider, which inherits from Scrapy's Spider class. The Spider class is a basic class provided by Scrapy that can be used to scrape data from websites. By creating a new class that inherits from Spider, we can customize the behavior of the spider to suit our needs. Inside the BlockSpider class, we have a few attributes. Name is a string that identifies the spider name. We can set it to anything we want. Then we have the start URLs. This is a list of URLs that the spider will start crawling from. The parse method is responsible for parsing HTML of the web page and extracting the data we want. The parse function takes an argument called response, which is an HTTP response that Scrapy received after making the initial request. Inside the first loop, we use Scrapy CSS selector to find and extract data we need based on the CSS classes and IDs. We then return the extracted data in a dictionary format. Inside the second loop, we use Scrapy's response.follow method to generate a new request for each link with a class of next. This is the link of the next page we want to scrape. This method takes in two arguments, the link that we want to follow and the method we want to use to handle the response. In this case, we're telling Scrapy to call the parse method again to handle the response from the next page. Now that we got a quick introduction to Scrapy and how it works, we can start adapting the code to scrape the Narutopedia website. Let's change the name and the start URL. This URL is the URL that contains all jutsus from the Narutopedia website. Then let's define how the code iterates to the next page. All we have to do is go to the website and inspect it to find the specific anchor tag that goes to the next page. We can copy its class name and paste it in the CSS selector. For each page, we want to go through each jutsu and click on its link, then scrape its title, description, and classification. If we go back to the website, we'll find that the jutsu anchor tags does not have a unique class like the one before. So we can extract all anchor tags in a specific div. We can see there's a div with a class called SMW column list container that encapsulates all jutsu's anchor tags. So we can extract this div and then extract all anchor tags inside of it. We can specify extracting the href attribute using this. For each link, we want to create a request that calls the function called parseJutsu that opens the link and extracts the data we need. Let's then create this parseJutsu function. First, let's extract the title. We can see that the title has a CSS class that we can use in the CSS selector again. Let's then return back the data in a dictionary. Let's run that and see the results so far. Before running it, we can change the yield to a return to just run that on one link instead of all links. To run Scrapy, we write Scrapy run spider, followed by the .py file, then followed by -o, and specify the output path. We see the expected scraped data in a JSON format. Let's delete the file and continue coding. Next, let's extract the description. The div containing the description contains a lot of unnecessary sections that we need to remove. We specifically want to remove this add section, this table section, and this trivia section. We can extract the whole div using the CSS selector normally, and then use beautiful soup to extract the text we want. We find that the add is in a div with this ID, so we can use soup to remove this section by using the decompose function. We can put it in an if condition to handle pages that doesn't have this section. Let's do the same thing for the title and the anchor tag of the quiz section as well. Let's tackle this section next. This section is called an aside section. Before removing it, we want to extract the jutsu type from it. We can use soup to get the aside section. Then we can loop over each row in the aside section and extract the text of the div that has classification in its h3 tag. Afterwards, we can remove the aside section. Now we can extract all text from the remaining sections in the soup. We will just have the trivia text left. We can split text by the word trivia and take the element at position 0 to get rid of the trivia section. Let's add the extracted data in the return dictionary and change return back to yield. Now let's run it again. After it finishes, we can see that we have successfully scraped all jutsus and their data from the Narutopedia website. Next, let's tackle creating the character network. We will want to read in the subtitles, then separate it into sentences and extract the named entities per sentence. Then we want to count how many times each pair of characters were mentioned within a 10-sentence window. Now we can easily convert this into a network where the nodes are the characters and the count is the edge attribute. We'll need to read in the subtitles data first. We can find that every episode has its own file. We can check out the data format by opening one subtitles file in a notepad. We can see that there are a couple of lines at the beginning that we don't need. Then, the data is comma separated with 10 columns. We'll only need the last one. The last column may have commas inside of it. We'll need to handle that when reading the data. Let's use the glob function to get all subtitle file path. We'll import it, then write glob, then give it a regex expression for the files. Let's write the folder path followed by a star, then the file extension. And here is the first 5 elements of the output. Because the last element has multiple commas, we won't be able to read the data using pandas. Instead, we'll open the file, read all lines, and then skip the first 27 rows that doesn't contain any data we want. We can then loop over each line and split the line by commas and take all elements starting from the 9th position, effectively dropping the first 9 columns that doesn't contain the data we need. Then we can join the rest of the list into a single string separated by commas with the .join function. In the data, we have //n that basically indicates a new line for formatting purposes. We can replace it with a space to clean the text a little. We can then merge all strings together into one single string separated by a space by the .join function. Let's also extract the episode number and the file path and append the subtitles and episodes in lists. Let's put the data into a data frame and print its head. The first thing we need to do is extract the named entities. We can use Spacy for this. Let's import it and load an NLP model. We can call the NLP function on a sentence to extract the named entities in it. We can loop over the entities and see the entity and its type. We can extract multiple entity types including geographical entities and not only person entities. Let's now extract all person entities for each sentence we have in our subtitles. The output should be a list of NERs per sentence. So the index position indicates the sentence index and the list at this index indicates the list of NERs from the sentence. Let's use the pandas apply function to conveniently loop over the rows of a column and apply the specified function on each row and save the results into a column. Let's now define the getNERs function. This function will take in the subtitles as input. We can divide the subtitles into sentences by using NLTK send tokenize. This divides the document into a list of sentences. Then we can loop over each sentence. Then run the NLP function on the sentence. Then we loop over all extracted entities. If the entity label is a person, we take its text and then extract only the first name from the text. Then we add this name to a set. We are using a set here because it assures that all elements are unique. We don't need to know whether one name appeared multiple times in a sentence for our use case. Then we add this set into an NER output list. For each time 2 characters appear within 10 sentences, we want to add those 2 characters to a list. Let's loop over the NERs column, and for each row, we can loop over each sentence. I add the list of NERs to a list that contains the entities in previous sentences. Then I take only the last 10 sentences. Because now this is a list of lists, I can flatten it into 1D list using the sum function like so. Let's now loop over each entity in the current sentence and loop over each entity in the previous 10 sentences. If the 2 entities are not the same, I sort the entities based on their names and add them to an output list. By sorting the list, we ensure that the first entity always comes before the second entity, regardless of the order in which they were originally encountered. This means that the entity relationships like Naruto and Sasuke and Naruto will always be represented as Naruto and Sasuke, which avoids duplicating information and makes it easier to analyze data later. Then we just append it to the output list. Let's now create a data frame with a column called value that has the entity relationships. Then let's divide the 2 NERs into separate columns. Now we want to count how many times each character pair appeared. The higher this number is, the more connected those 2 characters are. To do that, we can count all occurrences of the source and target by using the group by function with the count aggregate function. Now we have 1 row per character pair. We also have the number of times that they appear together. We can choose the top 200 character pairs, as this will make our graph a little bit less crammed. Creating a network is easy. We can use the networkx library and use the nx.fromPandas edgelist function. Let's give it the data frame, the source column, the target column, and the value column as the edge attribute. And now we can plot the graph like so. We can already see character connections, but this is hard to interpret. So let's use pyviz to create another visualization. We can use the node degree as the node size parameter. The degree of a node is how many connections it has with other nodes. So here, the more connections a node has, the bigger the node size. This looks fantastic. We can see that Naruto is the biggest node since he is the main character. And we can see that Sasuke and Sakura has the strongest connections to Naruto, indicated by the thickness of the edge. We can also analyze other characters like Guy Sensei. We see him having the strongest connection with Lee, which makes sense. Next is going to be theme classification. For that, I am going to use an NLP zero-shot classifier. A zero-shot classifier classifies text into categories even if it's not been explicitly trained on those categories. Those types of models takes in 2 sentences, a premise, and a hypothesis. The premise here is going to be any text, and the hypothesis is going to be the class name. The model classifies both sentences as entailment, neutral, or contradiction. This indicates whether a text belongs to a certain class or category. This can be also called natural language inference. For scenarios where we don't have any labeled data, this is the best approach we can take. First, let's read the subtitles data like before. Then we can initialize a Huggingface zero-shot classifier with the pipeline function. I am using Facebook's BART model that was trained on a multi-genre natural language inference dataset. Huggingface will pull this model from its model zoo, so we don't have to manually download it. To run the zero-shot classifier, we can give it a set of labels and the text we want to classify. We also have the option to specify whether this is a multi-label task or a single-label task. The output is going to be like this. Let's do that for all our data. We can use the pandas apply function and give it the getThemes function that we will create now. This will loop over each row, running them through the getThemes function one by one. Since BART is a transformers model, it has a maximum number of tokens that it can take. So we need to split the text into multiple batches. Let's split it into batches of 20 sentences. Let's use NLTK send tokenize to split the text into a list of sentences. And then we can create a for loop that starts from 0 till the length of the list of sentences and increment the index by the batch size. So the index starts from 0, then goes to 20, then goes to 40, and so on. I then take a subset of sentences starting from the index till index plus batch size, and I join them together into a single string separated by a space. Then append this text to the script batches list. I then define some candidate labels. Those are just some themes I noticed when watching the anime. I also added a dialogue label which indicates that this is just a dialogue and not a theme. This will help the model to get better performance since a lot of the subtitles might be just chatting between characters. Then I just run the zero-shot classifier on the data. Now I want to get the mean values for each candidate label across the 20 sentence batches to get the final episode score per label. I first triangle the output so that it can be in a dictionary format where the key is going to be the label and the value is going to be the list of scores. Then I take the average of that list and return it. I can now change the output into a data frame and join it with the current data frame like so. I can then sum together all theme scores to get the end result. Let's also plot it on a bar chart to visualize the data. We can see that sacrifice, battle, and self-development are the top 3 themes that Naruto has. The final model is going to be a Jutsu Classifier. Based on a Jutsu title and description, we'll be able to predict whether this Jutsu is Taijutsu, Nenjutsu, or Genjutsu. I have another tutorial that explains text classification with Huggingface in more detail, but I'll explain it here on a high level. First, we define some parameters like the dataset path, text column, label column, the Huggingface model we are going to use, test size, and number of labels. The model we chose here is the Distilbert model. Huggingface will automatically pull this model from its model zoo. Let's read the dataset using pandas. We can see that the jutsu names are quite comprehensive. We only need the Genjutsu, Taijutsu, and Ninjutsu part. We can create a function that takes in the comprehensive name, and if it found Genjutsu in the comprehensive name, it just returns back Genjutsu. We can do the same for Taijutsu and Ninjutsu. Then we can call this function on all rows by using the pandas apply function. Let's check the jutsu distribution. This doesn't seem to be normally distributed at all. We'll need to handle that in training by adding class weights so that the model doesn't ignore classes with fewer occurrences. Let's define the text column by concatenating the jutsu name and the description. And let's override the jutsu column with the jutsu simplified column we created. Let's just take the text column and the jutsu columns and drop any rows with any values, if any. Afterwards, we clean the text. This is just a good practice, but in our scenario, our text is cleaned and it doesn't need any cleaning. This simple cleaner removes any HTML tags and adds new lines after paragraph tags. But again, we don't really need it here. Depending on the text you have, you might need to add more functions to clean your text. Next step is going to be map our jutsu names to number IDs. This can be done easily using the sklearn label encoder. We can fit the data to the column and then transform the column. You now have the label column that has the class IDs. Because our dataset is not balanced, we'll need to add class weights that will help our trainer to focus on all classes and not just to optimize on the most common class. It does that by multiplying the class weight with the loss from the loss function, thus increasing or decreasing loss based on how frequent classes are. We can get those weights by using sklearn's compute class weights function. We tell it we want the class weights to be balanced and give it the classes we have and all the label column. And this is the output class weights. We see the class weights for Genjutsu is the highest because this one has the lowest number of occurrences. We can then split the data into training and testing datasets using the sklearn train test split function. This takes in the data, the test size, and we also tell it to stratify the dataset based on the label column. Stratify means that it splits the data into training and testing datasets per class based on the test size. This will ensure that 80% of each label's data is used in the training and the remaining 20% is used in testing. This is only important in unbalanced datasets. Then we can convert the train and test datasets into Huggingface datasets. And then we can tokenize the text in the training and testing datasets with the model-specific tokenizer. We then initialize the model and give it the model name that we defined above and the number of labels. Then we can set up the accuracy as our metric that we'll track after each epoch. Then we can set up a custom trainer that is an exact replica of the Huggingface trainer, but it takes class weights in the loss function. Then we can set up the training arguments. We'll specify the output directory that will have the model weights, learning rate, batch size, number of epochs, weight decay, evaluation strategy, and logging strategy. Then we can initialize our trainer. Then call the train function. The final step is going to be evaluating the model. We'll use sklearn's classification report for that. First, we evaluate the training data, then we evaluate the testing data. The classification report provides you the precision, recall, F1 score, and accuracy all in a neat grid. And this is it for our Naruto-themed data science project. You learned how to scrape data, use NER, create network graphs, utilize zero-shot learning, and train a state-of-the-art NLP text classifier. This project will be a huge addition to your resume. I hope you enjoyed the video, and thank you for watching.